Compound interest is where you earn interest on the principal as well as on the interest that the interest generates. In other words, you get interest on the interest. Simple interest again with linear growth, and it turns out that compound interest is exponential growth. You can see it grows much faster. So the advantages of compound interest is your money will grow faster. The disadvantage of compound interest is that what you owe will also grow faster. So let's talk about what compound interest formula looks like. Again, it looks a lot like the formula for exponential growth. Instead of P of t, we use F for future value. But it is basically a P of t. We use just P for present value or principal instead of P0, but it's basically the same thing. And then we have 1 plus R, but this time because we're doing compound interest, we have to factor in the idea that R might actually change depending on how many compounding periods there are. So you actually divide your R by N, and then you raise it to NT because you have to look at how many compounding periods you actually have in the life of the loan or the interest you're earning. So again, F is your future value, P is your present value, R is your annual percentage yield. You always write this as a decimal. T is your number of years, and N is the number of compounding periods per year. There's also something called continuous compounding. Continuous compounding is where you're always getting interest all the time. And we saw in the last chapter that E was what is known as the natural base, and that E shows up in compound interest formula. So it is, again, the same thing of F plus P, F equals P, E to the RT. It's just that this 1 plus R to the N becomes E as N gets bigger and bigger and bigger. So E again is that 2.71828 yada 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 number that goes on forever. It is an irrational number. So let's, as an example, suppose you invest $10,000 in an account paying 6.3% APR. Find the future value after 15 years. If the interest is compounded, let's say quarterly, then let's do monthly, then let's do continuously. So quarterly tells me that I have to use this formula because it's just compound interest formula, not the continuous. So the minute I see that I'm compounding quarterly, I know to come use this. Or if I'm doing compounding monthly or compounding annually or whatever it is, if I see the word compound, which I do right there, then you would go and use this compound interest formula. So I know to use the compound interest formula. So I'm going to start writing that down. And then my job is to figure out what all the pieces are. So P is how much you started with. So we started with 10,000. So P is going to be 10,000. 1 is just 1 plus. And then R is your annual percentage rate, which you write as a percent. So 6.3 becomes 0.063. And then quarterly means that you're doing it every quarter. So think of it as how many quarters are there in a year? Well, there's 4 quarters. So you start in, let's say you do April, then you go and do June, and then the next one is September, and then the last one is December. So there's 4 quarters in a year. So your N is 4 because that's what we go with. Again, you put 4 up here in your N, and then we asked for 15 years. So you're going to put 15 up there. And then I would just type all this into your calculator. Make sure you use the parentheses. This is the little caret symbol that will raise things to powers. And that way you don't have any rounding errors. If you do all these in pieces and then write down the numbers, you create rounding error. And it's not a good idea to do. So you can actually type this all in, 10,000, then put a parenthesis, and then 1 plus 0.063 divided by 4, close the parenthesis, and then a little caret, and in parentheses put 4 times 15. And that gives you this number. So your $10,000 in 15 years became $25,000. Let's say we can compound it monthly. Well, there are 12 months in a year. Everything else is the same. So the 10,000 is still the same, the 0.063 is still the same, the 15 is still the same. But now instead of putting a 4 here, you put a 12 because it's 12 months in a year. And as you can see, when you compound monthly, you get actually a little tiny bit more money because you're compounding and finding that interest every single month instead of waiting for every quarter. So your interest builds a little bit faster. Continuously means I have to use this formula. So the minute I see the word continuously, it means go grab this formula. So I'm going to take F equals P, E to the RT. Again, my P is still $10,000. my R is still the same at 0.063 and my T is 15. Since I'm now using this formula, I don't have to worry about an N because it's kind of built into that E. And then you can again do this on your calculator, type in 10,000. There is an E on your calculator. It is above the LN button, which is actually kind of near the number 4. If you hit the second button and then the LN button, you'll get an E for power, and then type this into the power, 0.063 times 15. Again, it's better to do that so you don't have grounding error. Notice you get slightly more money than you did when you did monthly. Now, let's say another example. Let's say you have $5,000 to invest at 5% interest compounded daily. How long would it take to grow to, let's say, $9,000? All right, so F is equal to P times 1 plus R over N to the NT is the formula again I'm going to use because I'm talking about compounding daily. So again, I use the compound interest formula. I want to find out how long it takes to grow to 9,000. So 9,000 is where I'm heading. So that's my future value. I started with 5,000, so that's where I'm starting the 5,000. And my interest rate is 0.05, or 5% of 0.05. And I'm compounding daily, and there are 365 days in a year. Some banks go and use 360 days because they're way old-fashioned. And when I mean way old-fashioned, it used to be the Babylonians believed that there were 360 days in a year. So I think that's why some banks still use that. I'm not really sure why they do. So we prefer to use 365 for daily because there's 365 days in a year. Granted, there's actually slightly more, but we're going to go with the 365. And then you've got your time. So the only thing I don't know in this formula is time. So I want to solve for T. So the first thing I'm going to do is get rid of this 5,000. And then I realize I've got my T up here in the exponent. So we haven't learned logs all that well just yet, but we've been exposed a little bit to them. So what you're going to do is you're going to take the log of both sides. And what that does is it allows you to bring that number, that exponent, down in front. So by taking the log of both sides, there's actually a rule that says the log of something to a power, that power can come down in front. Now, don't get frightened by the log. First off, log, you have a button on your calculator for it. Log is log base 10. And it's just a number. So you hit the button on your calculator and you'll find out what that number is. You just don't want to write it down because it's an obnoxiously large number. Long number, I should say, not large, but long. All right, so now we've got all of this. We've got the 365T, this log thing, and this log here. Again, I probably wouldn't have done where I do 1 plus 0.05 over 365 because this is now rounded, but it probably isn't too badly to round that. Now, T is what I want to get, so if I divide by 365 on both sides, that gets rid of the 365. And again, this log is just a number, so I'm just going to divide by that number on both sides. And then I can take the log of 1.8 on my calculator. Make sure the log, when you hit the log button on your calculator, it puts an open parenthesis. Make sure you close it before you do divided by. And then you're going to do parenthesis around this 365 log so that you divide by the whole denominator. So you have log of 1.8, close that parenthesis, open a parenthesis here, 365 log of all this, close that and hit enter. And you get 11.8 years. So you have to wait 11.8 years to have your $5,000 grow to $9,000 if you're compounding at 5%. Now, I don't know about, let's talk about this. Annual percentage rate is how much you're going to get in a year, but because you're compounding, you actually get a little bit more money every month or every quarter or whatever your compounding period is. And so we have what we call an annual percentage yield, and that's the percent profit of an investment generated in 1 year. So what we think of, the easiest way to figure this out is think of investing $1 for 1 year. And you're going to find that APY for an account with 8%, let's say APY, compounded annually, weekly, and continuously. So again, because we're saying compounded, we're going to use the compound interest formula. We're looking at just $1. So usually when you're doing the annual percentage yield, you're looking for $1. So you put $1 in there, and you can do it for 1 year. And since we're doing it annually, there's only one compounding period in a year, so N is 1. So we put those numbers in, and we come out that F is equal to 1.08. Now that's what the dollar's now worth. The dollar used to be worth $1. Now it's worth $1.08. So it gained 0.08 or 8%. So that's actually what your APY is 8%. Granted, that's exactly what we had before, so you don't gain anything much from doing this because you shouldn't with one compounding. Now let's do weekly. There are roughly 52 weeks in a year, not exactly. And so we're going to put 52 in wherever we see an N. Everything else is basically the same. And you get it's 1.08322. That's how much that dollar is now worth. So you gained 0.08322 is what your APY is. Or if you want to look at that in percentage, it's 8.322%. So you actually gain a little bit more than that 8% in a year. Continuously means use the continuous formula. So we're going to use the continuous formula, and this is what we get. And then we can see that we now have, putting that in to the continuous formula, you get 1.08329. Again, that's what the dollar becomes, and your APY is how much you gained. So you gain 0.08329 or 8.329%. All right, so that's how we do that. Now, most of us don't have money to put away, a chunk of money to invest. So we're going to talk about in the next section, what do you do to actually earn money a different way.